Hello guys, welcome again. My name is Bediakoh. I'm your instructor for your A-level review past questions that we've been seeing. I'm sure you are enjoying what you've been learning and going through. In our previous videos, you've seen several aspects of your A-level program that we've reviewed the past questions from the year 2015 up to now. In this particular section, or in this series of videos, we are going to look at calculus, differentiation, and integration. In a set of videos which will come in about 3 or more, you would see that the differentiation aspect has been broken down into 2. We have the first aspect where we look at the differentiation plus applications to stationary points, maximum and minimum, and rates of change. The second aspect also got to do with the same differentiation, but this time we focus on the applications that has got to do with the tangents and normals and also the equations. Then you have the other aspects of the integration that deals with the area under curve, the equations of the curves itself, and also volume and solids of revolution. So I'm sure you are enjoying it. Like we always say, practice is what's going to make you perfect. Make sure that you have your pencils, your pens, your calculators, and just take your time and go through all the problems that you'll be taking through here. Remember, go to our website www.learnwestafrica.com and keep up to date with the things that we are sharing with you there. Also, remember to subscribe to our YouTube channel. Also, click on the notification button there, and don't forget to also drop your comments within the comment section. On Facebook, like our page. We are also on Instagram, Telegram, TikTok, and WhatsApp. All other social media handles. Wherever you see Learn West Africa, please try and like it. So, let's set our balls rolling and get ourselves geared up into action. It's differentiation calculus for you. Thank you. So, this is QP11, the first variant of our question paper, and question 9. Question 9. Now, question 9 says, the equation of a curve is y equals to x cubed plus px squared, where p is a positive constant. I. Show that the origin is a stationary point on the curve, and find the coordinates of the other stationary point in terms of p. II. Find the nature of each of the stationary points. Another curve has equation y is equal to x cubed plus px squared plus px. III. Find the set of values of p for which this curve has no stationary points. Yes, so like the question just showed up there, this is summer 2015, the question that was just showed. That was question 9, question paper 1-1, the first variant question 9. Like we've just been told earlier in the introduction, this aspect we are focusing on differentiation and this application, specifically stationary points, maximum, minimum, rates of change. Okay, so the other aspects, when we get there, we'll look at it. Stationary points, maximum, minimum, rates of change. So what does the question say? I'll just repeat it for emphasis. Like it was just shown that the equation of the curve. So we're given the equation of the curve, and we said that it is y equal to x cubed plus px squared. Okay, and we were told that p is a positive constant. We are saying that we want to show that the origin is a stationary point on the curve, and also we want to find the coordinates of the other stationary point in terms of p. Are we okay? So the origin is a stationary point on the curve, and also what will be the other coordinates of the stationary point. Now, let's get this. Stationary point, like we all know, it is the point at which we are saying that the curve is neither increasing nor decreasing. Guys, are you okay with that? The point at which the curve no longer increases, neither does it decrease. Then we say that that is the stationary point. In calculus, you do understand, and that's the essence of the differentiation. dy dx measures the rate of change. Please get it. Dy dx is the rate of change of the curve at any particular point. So if the curve is changing, how you measure that rate of change is your dy dx. So when we want to differentiate, the purpose is to find the rate of change. So if you want the stationary point, what it means is that the change is no longer existent. Because if you are not changing, you are not increasing, you are not decreasing, what is the meaning? It means you are stationary. Okay, so we are saying that we want to find that the origin is the stationary point, which means that we need to find the point at which the dy dx, the change, is non-existent, and therefore what happens when dy dx is 0. Hope I'm clear. Okay, so now let's try and find dy dx of this relation. Okay, so the dy dx here is going to give us, like we know, using the power rule, as you've seen in the revision course already. This is going to give you 3x squared plus 2px. Okay, so this is the derivative function, like the gradient function, dy dx, and we are saying that stationary point, so dy dx is 0. So let's equate this to 0. So we can just say that dy dx is equal to 0. What happens there? This is going to give you 3x squared plus 2px. What do we get from this? So this is going to give us x into bracket 3x plus 2p. Okay? Then we equate it to 0. As we said, we equate to 0. So the whole of this will be equal to 0. Therefore, we can say that x equal to 0. Then we can say 3x plus 2p is also equal to 0. All right? So that gives us x equal to 0. And from this, you can find your x to be equal to, so that one go there, minus 2p divided by 3. Then you are going to have minus 2 over 3p. Are you okay? So the problem says that we should show that the origin is a stationary point, and that's what we found. Because once you have x equal to 0 in here, and x equal to 0 is the origin. The origin is like the beginning of your Cartesian plane, x0, y0. So once for the stationary point, you've been able to get x equal to 0 in there, it is obvious that that is okay. And there's the other part, okay? All right, so let's look at the second aspect of the problem. Now, it says that we should find the coordinates of the other stationary point in terms of p. Find the coordinate of the other stationary point in terms of p. The other stationary point. So we know that for the other stationary point, you should have an x component and the y component. The x component is minus 2 over 3p, no problem. So what is the other part? Okay, which means we need to find the y component. And for the y component, we have a relation for the y. Okay, so let's just come here and just write it. Y is going to give you x cubed plus px squared. And remember, we are going to make a substitution with the x value. So this is our x. Okay, so we're going to have minus 2 over 3p, your x cubed, plus p. Then this one also gives you minus 2 over 3p. Okay, so what happens here? You're going to have minus 8 over 27p cubed plus. Okay, so that's going to give you, okay, there's a squared here, all right? So that's going to give you positive 4 over 9, okay? So this p, then you're going to have 4 over 9 p squared. Hope it's clear. All right, so let's just simplify that. You're going to have minus 8 over 27 p cubed plus 4 over 9 p cubed. All right, so that's very simple for us to do. We just have to add the minus 8 over 27 plus 4 over 9. And what do you get for that? Let's just do the fraction for that. You're going to have 27 here. So you have minus 8p cubed plus, that's going to give you 12p cubed. And what is minus 8 plus 12? That's 4, okay? So that's going to give you 4p cubed over 27. Take a moment and look at it. We are clear? All right, so we can say that the other coordinate apart from the origin will be, the x part will be what? Minus 2 over 3p, and the y part will be 4p cubed over 27. All right, so that is how we deal with the first part of the problem. Question 9, QP 11, 2015. Okay, so let's look at the II part. The II of question 9, QP11 says that find the nature of each of the stationary points. Find the nature of each of the stationary points. Like you well know, when you are asked to find the nature of the stationary point, we want you to simply tell us, or the question just wants you to tell, to determine whether the point, the stationary point that has been found, is either of a maximum stationary point or a minimum. Simply put, the point at which the curve is stationary. Has the curve reached its maximum position or it has reached its minimum position? That's simply essentially what we mean by trying to find the stationary point, like the nature of the stationary point. And we know what that means. You take your second derivative, d square y over dx squared, or dy2 over dx2. Okay, so let's look at the function again. Yeah, so this was what we got for the first derivative. We know that for the function, we saw that dy dx was equal to 3x squared plus 2px, correct? All right, so now we want to find the nature of the stationary point. Remember, we found two stationary points. One of them is the origin, where x equal to 0, and the other is where x equal to minus 2 over 3p. Okay, so stationary point, STP. This is not chemistry. STP, stationary point. Okay, so the square y over the x2, okay? So what do we get there? We take the second derivative. So now this is going to give us 6x plus what? 2p. Are you okay? That's the second derivative. So we now slot it in there. Okay, so now let's look at the case of where x is equal to 0. So at x equal to 0, what happens? Our d2y over the x2 is going to give you 0. So this is going to give you 2p. Do you see that? So if your 2p is greater than 0, what's the conclusion? Anytime your second derivative is greater than 0, then it means that point is a minimum point. We know that. Okay, so we can say that at x equal to 0, the curve is what? Is minimum. The curve is minimum, which means that the nature of the stationary point x equal to 0 is that the curve is minimum. That point is a minimum point for the curve. Okay, now let's look at a situation where the minus 2 over 3p is put. So we can say that at x equal to minus 2 over 3p, what happens? We do the same replacement or substitution. That's going to give you the 2y over the x2. Let's see what happens. This is going to give us 6 into brackets minus 2 over 3p plus 2p. Okay, so what happens there? Here is going to give you minus 3 will go there, minus 4p plus 2p, okay? So what happens there? This is going to give you minus 2p. All right, so at the point x equal to minus 2 over 3p, what happens is that the square y or the 2y over the x2 is negative. What's the conclusion? Anytime your second derivative, your d2y, the x2 is negative, your curve is maximum, okay? So the nature of the stationary point, x equal to minus 2 over 3p, is that it is a maximum point. So we can say that at x equal to minus 2 over 3p, the curve is maximum. Take a second and look at it. You understand that? Because this is less than what? 0. So your curve is maximum. So by this, we've been able to deal with the II aspect, which required of us to determine the nature of the stationary point of these two. Is that at x equals 0, it is minimum. At x equal to minus 2 over 3p, the curve is maximum. Okay, so now let's look at the third part. The third part, we were given a preamble there. And the preamble was that if the equation y is equal to x cubed plus px squared plus px. Okay, so there's another curve there. And the question is saying that we should find the set of values of p for which this curve has no stationary point. So find the set of values of p for which this curve has no stationary point. What do? We know the fact is simple. When we say stationary points, we are referring to the values that will satisfy our dy dx being equal to 0. That's essentially what our stationary point means. So let's try and figure that out here. So what happens? We take our dy dx. So when we have dy dx, this is going to give us 3x squared plus 2px plus p. Hope you're okay. So what do? We can use factorization to resolve the problem. We can use factorization to resolve the problem. So for our stationary point, we're going to say that our dy dx should be equal to 0, which means that we equate that to 0. Now when you do that, okay, and we are saying that it has no stationary point. It has no stationary point. So what simply we want to mean is that our b squared minus 4ac, okay, should be less than 0. Our b squared minus 4ac should be less than 0. Our determinant should be less than 0. Then if it's less than 0, then it means that the quadratic has no solution. What are those values like that? I hope you're okay. This is the discriminant. The discriminant will tell you the nature of the roots of the quadratic. So if this quadratic should have answers for p, then it means that there are values of p that will make the equation correct, and therefore you have the 0. But we are saying that we want to find the values of p where stationary points do not exist. If the stationary points don't exist, then it means that that one is going to have an issue. Our discriminant there should be less than 0. So what do we find? B squared minus 4ac. Okay, so our b squared minus 4ac is going to be b, which is 2p all squared minus 4, and our c is p, should be less than 0. So this is going to give you 4p squared minus 12p less than 0. Are you okay with that? So what happens? We are going to have our p squared minus 3p less than 0. So when you're able to work this out, this should give you your p falling in between 0 and 3. So when you have any value of p that falls between 0 and 3, what is going to happen is that this particular expression will not be equal to 0, and therefore the stationary point will not exist for values that are between 0 and 3. So that is how you go through that part. So that brings us to the end of the third part of the question 9. That came in your variant 114. Okay, so now let's look at the year. Again, the variant 12. Okay, so QP 12, question paper 12. Question 4. Question 4. It says, variables u, x, and y are such that u is equal to 2x into bracket y minus x, brackets closed, and x plus 3y is equal to 12. Express u in terms of x, and hence find the stationary value of u. All right, so like the question just showed, we are saying that the expression for the u is 2x y minus x, okay? And you have x is equal to, no, x plus 3. Let's just rectify that. X plus 3 y is equal to 12. And we are told to express u in terms of x, and hence find the stationary value of u. Express u in terms of x and find the stationary value of u. Okay, so let's express u in terms of x. In terms of x, what simply means is that we need to replace anything else in the expression that is not an x and put an x there. That makes it very simple, right? So we just take this expression and just try and find the value of y in terms of x. So our y is going to give us 12 minus x all over 12 minus x all over 3. Hope you're okay. So that's the value of our y. All right, so let's try and do this expansion. So we know our u, the u is going to give us 2xy minus 2x squared. Correct? Okay, so now we just plot our y in there. So our u is going to give us 2x. Then what is our y? 12 minus x all over 3. Okay? Minus 2x squared. Hope you're fine with that. Okay, so what happens? Let's try and expand this. We are going to get 2 over 3 x into brackets 12 minus x minus 2x squared. Okay, so we'll just take our time and just deal with it. We are going to have our u being equal to, this is going to give you 24x over 3 minus 2 over 3 x squared minus 2x squared. Hope we are fine. Okay, so what happens here? These are like terms, so I think we can just put them together. So 3 times that will give you 3 times that will give you 6. So minus 2x squared minus 6x squared. So our u is going to give you 24x. 24 over 3 is 8, right? So let's just try and reduce the calculations. So this is going to give you 8x. Then 3 times that is 6. Minus 2 minus 6 is minus 8. So minus 8x squared all over 3. So this is u. Okay? So a bit of algebra there we've worked out. Now the problem continues and asks of us that if you have this situation, what is the stationary value of u? We should find the stationary value of u, which means that we just want to differentiate dy dx, okay? Okay, or du dx, and we would equate that to 0. So what is that? Okay, so let's find the stationary value. So what's the stationary value? So let's take the u dx. The u dx. What do we get for the u dx? So that's going to give you 8. Then these two will come, then you get 16, right? Minus 16 over 3x. Okay, so this is the u dx, and we say we want to find a stationary value. So let's equate it to 0. So we're going to have 0 equals 8 minus 16 over 3x. And that's going to give you 16 over 3x equals 8. And therefore, our x should be 24 over 16. All right, so you can just simplify that, 24 over 16. So this is going to give you the x component of our stationary value. The x component of our stationary value. The x component of our stationary value. So if you get the x component of stationary value, you can just slot it in there to find the value of y or the value of u. Okay, you'll be able to show that your u is equal to 8x minus 8x squared all over 3. Okay, so I'll leave you to just do computer calculation. Simplify the value of x. Whatever you get, you put it into the u, then you find the stationary value of u. So that is the question that came. How you deal with that. Now this is question 8. QP12, question paper 12, question 8. The function f is defined by f of x is equal to 1 over x plus 1 plus 1 over x plus 1 all squared, all into brackets, for x greater than minus 1. I, find the first derivative of x. II, state with a reason whether f is an increasing function, a decreasing function, or neither. III, find the coordinates of the stationary point on the curve y is equal to x. Okay, so like the question was just being asked of us in question 8, QP13, the variant, the function that was given is this. And remember that the domain was given, the domain like the values that you have to put in, and the problem said that where the x is greater than -1, where x greater than -1, and we're given this, and we've been told to find the first derivative, f complement of y, the first derivative. Okay, so the first derivative, as we know, simply means that we just have to differentiate the function. Okay, so when you have f of x like that, and it's been given as 1 plus x plus 1 plus 1 over x plus 1 all squared, and you've been told to find the first derivative, what do we do? Okay, so we can just rewrite this f of x to be x plus 1 minus 1 plus x plus 2, no, x plus 1 minus 2. All right, so now let's find the first derivative. What do? We just apply the basic understanding, what we know about composite functions, how we can use composite functions, like how to use the composite rule to differentiate functions. So let's just go straight. So f complement of y, or first derivative of x, of the function, is going to give you minus 1, okay? X plus 1 minus 2, okay? Times, we go inside and differentiate. So when you differentiate what is inside, what do you get? This is going to give you 1. That will be like inconsequential as to what you get. So there's no need to even bring that. Then we come here. So the minus 2 will also drop. So this is going to give you minus 2 into bracket x plus 1 minus 3 times, we differentiate what is in there. That also is going to give you 1. So in effect, your first derivative of the function is going to give you minus 1 all over x plus 1 all squared minus 2 all over x plus 1 minus 3. Are we okay with that? So this is your first derivative of your function. That's what you get. So with this, we are done with the I part of the problem. Now watch what we were also told in there. The second part says that we should state with a reason whether f is an increasing function, a decreasing function, or neither. State with a reason whether the f is an increasing function, a decreasing function, or neither. Now watch. Keep this at the back of your mind. For a function to increase or decrease will depend on its rate of change. You understand that? If the rate of change of the function is positive, then we can say that the function is an increasing function. If the rate of change is negative, then we say the function is a negative or a decreasing function. If the rate of change is not existent, then we say that the function is neither of the two. The rate of change is found by the first derivative. So anytime you work out the first derivative of any function, and it gives you a negative answer, a negative derivative, that function is a decreasing function. If you work out the first derivative of a function and it gives you a positive derivative, that function is an increasing function. So now let's look at what we have here. You see a negative value. So minus 1, also subtract negative 1. So what is the trend of this? Do we see that this function goes into a negative? So once the first derivative is negative, we can say that for the II part, for all values of x that are greater than negative 1 for the domain, this function will be a decreasing function. So that will answer the II part of the problem. We will say the function is decreasing because its first derivative is negative for all values of x which are greater than negative 1. Okay, so now let's look at the II part. Okay, so the II part, as we have been requested, is saying that we should find the coordinates of the stationary points. We should find the coordinates of the stationary point. So we know that for the stationary point, your f prime of x should be equal to 0. Okay, or your first derivative should be equal to 0. So what did we get for the first derivative? If you remember, we had minus 1 over x plus 1 all squared minus 2 all over x plus 1 cubed, and we are saying that this is equal to 0. Just take a second look at it. So this is what we want to resolve, okay? We want to find the value of x which makes this one true. So this function can go there. That's going to give us 1 over x plus 1 all squared equal to 2 over x plus 1 cubed. All right, so now let's see what happens here. We can just do a quick dash. We can bring this one here, bring the negative down there. It doesn't really change a lot of things, yeah. So we're going to have our x plus 1 all cubed all over x plus 1 all squared is equal to 2 over minus 1. Are you okay? Just look at it, you should be able to understand the rearrangement. All right, so what happens? You're going to have your x plus 1 is equal to minus 2. Okay, so our x plus 1 equals to minus 2. What do we get? What do we get for that? Okay, so we're going to have our x is equal to minus 2 minus 1. Your x is going to give you minus 3. All right, so the question is saying that we should find the coordinates. We should find the coordinates of the stationary point. So now we've been able to find the coordinates, the x part, x equal to minus 3. Okay, so you can just try that. Just put the x equal to minus 3 into your original function, and what you get for the function will give you the corresponding value of the y, and that should give you the coordinate. So the most important part is what we have tackled, arriving at the fact that at x equal to minus 3, you can have your stationary point of your curve. So with x equals minus 3, slot it into the function, simplify, then you have your answer there for you.